All right.
So as a preliminary demo of our product, we just wanted to first off show the usability of the analog discovery kit. And so in order to do so, we had to load the software onto the computer. And so what I'm going to do is generate a signal that'll come from the analog discovery device, and it'll come through in channel 1.
Mm-hmm.
And then that signal, you would be able to see the actual frequency of that signal as it displays on the oscilloscope. And as it implements or relates to our demo product, we put in the input, the audio input into the analog discovery so that we can listen to this frequency and amplify it through the system where it goes from one speaker to the master speaker to the slave speaker. So just to start off by running that, that's the frequency of a sine wave signal. As we increase the amplitude, the volume of the signal increases. And as we increase the frequency, the pitch of the signal increases. And it is amplified through our system using the speakers that we have set up. This relates to our project in that we want to have overall a wireless design that would allow us to connect input signal to be amplified to multiple output speakers or output peripheral devices via Bluetooth. And as a stage 1, we just did it through a wireless connection. I mean a wired connection. And
What are these? All these
I'll let
things about.
Kadeem and Christian give you a little bit more specifics about what's going on in the circuit.
Okay, so first of all, we downwired these 2 speakers. So this speaker would be the slave. So that's why I implemented a switch to prove that without one, the other can't receive any information. So in our sense, that would be where our connection, right now we're just wired, it's wired right now. So the switch implemented to prove, yeah, it's wired right now. Mm-hmm. So this is a slave. So once the switch is open, the master still works because it's still receiving information directly. And once the switch is released, both speakers is getting the information from the master. The first switch is just to control everything, so it's off, all the audio is off, nothing is happening.
Mm-hmm.
So with the use of our project, it would be basically at the beginning of this connection. So the input, our chip that we would, I guess the software implemented, and we would program it so that it would control information that's being spread out. And we'll also have, I'm guessing, the ability to control what happens to the slave. So the slaves are dummy unless we want it to be. So that's how this is set up right now. So
they're both on, right?
Yeah. So unless we want the slave to be off or on, it doesn't matter.
But both are being fed by the same wire, right? It's the same source.
Yeah, through a switch.
What I do?
Yeah, you didn't do nothing. I don't think.
Yeah,
But
they can't.
This is the noise. It's supposed to go in there.
Okay.
All right, so the sinusoid. Okay, I get the point. The sinusoid is being generated from the function generator on analog discovery device?
Yes. From the waveform generator, the sinusoid is being generated from the waveform generator.
So that doesn't have to be connected to the board in order to do that? How are you? How is it getting from these terminals to the board?
In terms of the frequency, we're listening to the frequency that's being passed through from the functioner. So there's channel 1, which has the waveform generator on it, and we send that through, and then
So you're basically listening to the signal that you're monitoring with the oscilloscope?
Yes.
Is that what you're saying?
Yes.
Okay.
Yes.
All right. And so that just broke off just like
so
that.
it's not,
Yeah,
the sound is not going to come through.
Yeah,
It cancels the noise. So
Yeah,
What did you do with the tone? You put it in there?
Yeah, I tried to put it in there, but this is so basically I can't take it out because it's being hardwired way in. But there's also a noise cable like this.
Is this a stereo channel?
well, both.
No.
Yeah, there's a left signal, a right signal, and then there's a noise cable that helps to clear up the noise.
Okay. All right.
I mean, if I plug it out, I don't know how deep is it.
It's not deep.
So yeah, we would have to strip this wire and actually reveal the cable.
Yeah, just cut it out. All right. All right. Why do you have two channels hooked up?
You only have
That's
channel.
one is ground, and
Yes.
then you're monitoring between two terminals.
Yes.
All right. I should have let you answer that actually, but that's fine. And these are powered by batteries. Is that right?
Yeah.
Mm-hmm.
So it needs the battery
That's what
needs
it's
to
going
be
to
on. Well, can't hear anything now, but okay. All right. But yeah, if you can recreate that really quickly. I think we'll be done. So you're saying your leftover part, this is what you're calling a leftover part? The speakers?
And we had all of this with these wires as well as the speakers and the switches.
Well, you got the speakers from me.
Yeah.
So,
The switches, the wires.
but you didn't mention either one of those in the presentation, right? Yeah. For your parts. All right. You think y'all covered everything on the demo rubric?
I think so.
You making a tone now? Or what?
Yes.
It's
It's the same signal. We can
Or is it low frequency?
we can change the signal. This is a custom signal that we had. Increase the amplitude so it doesn't be as loud.
What happens when you change it now? So what? Okay. Can you do it again? I ain't to it. Alright, so there's something that, which are the function generator outputs?
The function generator outputs.
Which one are function generator and which one are the scope?
So
outputs?
channel 1 is the other is channel 1. Oh, it is. Okay, so it's. Oh, this is so that it can transfer that signal to the oscilloscope. So what happens is it comes out of channel 1, which is the waveform generator, and it sends it to, well, it comes out of the waveform generator, it sends it to channel 1, where the and then the oscilloscope reads it on channel 1. You can see here, this orange line represents channel 1.
Right.
So the actual orange line is channel 1. So once you connect the waveform generator directly to channel 1, you will see the the actual waveform. If you take that out, it'll stop, so you don't see the waveform on the oscilloscope.
Right.
Ground is just ground, but you can see
All
it
right.
without ground.
Put one of those waves up there, maybe the triangle wave. Increase the frequency or something, or decrease. Alright, so just leave it there. So why is it still making noise when you disconnect?
Because we're listening to the actual signal from the waveform generator as the oscilloscope reads what is that signal. So in terms of direct contact
you're listening
to the frequency of
the signal from the generator,
yes.
not the scope.
Yes.
Okay. All right. All right then. I got any other comments?
Other than
Any other points
us
you wanna make?
generating that or showing that interaction with the analog discovery, it also does play the music through the system as well as if we connect a device. I don't know which one it is. Has the music on it.
Right. You don't have to worry about it.
Yeah.
It's just a connection. All right.